Hello everyone. This is Hao Yian. Today I'd like to talk about my final research paper. The title of my paper is a comprehensive survey on the cost of modularity and refactoring in OOP. As we can infer from the title, it mainly talks about two terminologies in object-oriented programming, which are the modularity and the refactoring. So let's get started. This is a structure of my paper. First is abstract. It summarizes the major aspects of the entire paper. That includes the overall purpose of my study and the research problem, and also the significant findings and the result of my analysis. Then is the background introduction that covers a couple of things, such as the evolution of the software development paradigm, the formation of the concept of both modularity and refactoring, and also how the concept of refactoring comes into being. Then is the related work. In this part, I will talk about the fundamental knowledge about modularity and refactoring respectively. Some concepts like the definition, benefits, as well as some primary principles related to modularity and refactoring. Then after that is the main body of my paper. I will show some investigation of the causes of modularity from different perspectives. For refactoring, I will categorize the causes into two separate sections. One is the challenges, and the other is the risks. And after that, I will conclude my work and give some insights to the future work. And finally, is a slide that shows the references I used in my paper. Okay, let's talk about the introduction of the paper. As the first software was created in 1950s, the software development has evolved over the past few decades. There are mainly three kinds of software paradigms that are the procedural, data-driven, and object-oriented paradigms. Compared with the procedural and data-driven paradigm, the object-oriented paradigm retains the best characteristic and also overcomes and minimizes their worst characteristics. So in this paper, we'll mainly talk about the object-oriented paradigm. And one of the most important features in OOP is the modularity, which means to make multiple modules first and then link and combine them to form a complete system. So even though for a well-defined software system, the system will become more complex in order to adapt to new requirements. But after that, it will drift away from original design and decay as the software is modified. So in order to fix those problems, an approach comes to our mind. It's called refactoring. Refactoring structures an existing body of code, alters the internal structure, but it doesn't change the external behavior of the code, and therefore the quality of the software will be improved, which contains like the maintainability, reusability, complexity, extensibility, and also the efficiency. So after the background introduction is the problem statement. Even though the modularity and the refactoring are widely used nowadays, I think it is very necessary and helpful to figure out the challenges and risks when using them. So in order to do this, some questions are raised to help us. Let's go through them. First is what kind of software needs to be modularized. So at the very beginning, we need to make sure if our software system needs to be modularized or not. And the second is that when we do the modularity, what problems it may introduce. And thirdly is when we want to achieve the modularity, what additional efforts are needed? So these questions are related to the modularity, and the following questions are about the refactoring. First one is that, so before doing refactoring, we need to know whether or not our software system needs to be refactored. And if it needs to be refactored, what effort does the refactor take? And also, we need to find out the challenges and risks of refactoring. Okay, so let's have some basic knowledge about the modularity. So a module is a group of applications and data structures that collaborate to provide one or more services to the rest of the software. A software that consists of just one single module is called a monolithic software. Because there are too many dependencies and references inside this software, it's hard to be maintainable and understandable. So in order to fix this issue, the concept of modularity comes to our mind. The modularity is the process of decomposing a program into a set of modules to reduce the overall complexity of the problem. Just like the figure on the right side, there are several modules for the puzzle, right? So these modules can form different shapes when they are placed at different places. So we can easily remove or change each module without it affecting the other modules, but it will change the whole functionality of the system, right? So, and there are some principles for using modularity. One is the heading information and encapsulation, and then is changeability, maintainability, and reusability. And the last one is commonality of goal and the similarity of purpose. I think these principles are quite easy to understand and intuitive. So I just want to explain the last one, the commonality of goal and the similarity of purpose. So when we want to do some modularity or to develop a module, I think the functionalities or the purpose of this module should be as simple as possible. It cannot contain too much work, since if a module with too much information is hard to be maintainable and reusable. As I mentioned in the introduction part, software requirements are constantly updated. So software systems are always to be modified to accommodate these new requirements. So in this process, the software systems will become more and more complex, which may drift away from their original design and may even decay. In order to solve these problems, there is a methodology called restructuring. In our objective-oriented software development, we call it the refactoring. Refactoring will reconstruct the existing code of a software and change the internal part of code and keep the external behavior. In this way, the complexity will be reduced and the quality will be improved. The quality here mainly contains the maintainability, reusability, complexity, and also the extensibility. Okay, so far we got some basic understanding about refactoring. So let's look at this list, which shows the activities or steps which contains in a refactoring process. The first step that when we want to refactor our software, we need to figure out that which part of our software need to be refactored. I think it's very important. And after this, that we need to determine which refactor methods that we want to apply to the identified places. And also after step 2, we want to, before we apply the refactoring, we need to guarantee the refactoring will preserve the software behavior, since we just to create a body of existing code that changing the internal part and keep the same as the external part. And the number 4 is that we apply the refactoring, and after that we need to test or to assess the effect of refactoring on the quality of the software. That we need to use some criteria to determine the effects of refactoring. That the refactoring solve our problem, something like this. And the last one is that we need to maintain the consistency between the refactored code and the software artifacts, which were very important. Let's come to the main part. First is the cost of modularity. The picture below shows the cost of developing a software system. As we can see, there are 3 lines. 2 solid lines represent the cost of each module and the cost to integrate these modules, respectively. At the very beginning, there are not many modules to start with. The cost of each module is pretty high. With the increasing of the total number of modules, the cost of developing a single module reduces. As the number of modules increases, the cost of integrating them rises. The dotted curve or the dotted line, which shows the total cost of the software system, there exists an interval denoted by the letter M in the figure, in which the total cost is lowest. So we can have a conclusion that more modules is not always better. And there are some other types of modularity costs. For example, modularity is a kind of technique that requires high-level design choices based on experiment. In other words, someone who wants to apply modularity into his or her system should have enough experience support. Besides, the understanding to the specific domain is also a requirement. In conclusion, the developer or software designer should take all aspects into consideration. Another cost is that the modularity may increase the workload of the hardware. Let me give a simple example. We are about to develop a web application. At first, there is just one module. The web container may use just one process and one thread to run this application. With the increase of modules, the web container may need more processes and threads to support. And this is very common in web development. And there are also some other types of costs, like it may make the integration tests harder and slower, and also it may make the cross-cutting concerns more difficult. After discussing the modularity costs, let's have a look at the refactoring. Firstly, the challenges of a refactoring. When we talk about refactoring, we can easily summarize many of the challenges we face. One of the major challenges is that we are working on large code bases. There will be a large amount of inter-component dependencies, which makes refactoring extremely difficult. Besides, we also need to ensure the correctness after refactoring. Large code base means more developers in the team or teams. We need to spend more time on coordination with other developers. Another common challenge is that developers are lack of tool support for conducting refactoring, like the code review tools or refactoring engines. And also, since these challenges and difficulties I mentioned, developers prefer to do refactoring manually rather than using some refactoring tools, despite their awareness of some refactoring types are supported by the tools. The last challenge is the unit test. If there exists a unit test, it's much safe, since developers can run those tests to ensure the correctness. However, if there are no tests, developers need to go through the test scenarios. And what's worse, if there are no sufficient test scenarios, it will be a disaster. As we can see, there are two bar charts in this slide. The left one shows the percentage of developers who do refactoring manually. We can get some information from the chart that there are a bunch of refactoring types, like the rename, encapsulation, encapsulated fields, and the percentage differs from the 37% to 70%. As we can see, developers even prefer to do renaming manually without using the refactoring tools, which can reflect that they do not trust the refactoring tools. And the red chart shows some risk factors associated with refactoring. We will talk about this in the next slide. This part is the risk of refactoring. The primary risk is the regression. It is mostly from misunderstanding subtle corner cases in the original code and not accounting for them in the refactored code. Another one is over-engineering. It means you may create an unnecessary architecture that is not needed by any feature, but all code must adopt it. It's very common during my work experience. The next one is that we can hardly measure the value of performing refactoring. We can hardly measure the value of a bug that never exists or the time saved on a later and undetermined feature. Since there is no way to place the immediate value on the practice of refactoring, it's difficult to justify the management. Another common risk will appear when we deal with the code, which interacts with many external interfaces. It's very complicated and easy to lead to errors, especially for loose detect or string parameter interfaces. Last but not least, refactoring is truly a means of improving the design, but it cannot completely change the design. We cannot naively believe that it can completely change the design. In the above sections, I have explained the advantage and the disadvantages of modularity and refactoring. It helps us to have a clear understanding of the problems and the potential risks that may arise during software development and evolution process. Although this can give us a lot of insights and inspiration into what to think about before applying modularity and refactoring to our own software systems. Some further exploration could also exist. I listed two prospective research directions. First is calculating the degree of modularity. So far, modularity is regarded as a qualitative concept. How to define which modularization is best has not been discussed yet. So to assess the comprehensiveness of every proposed method, the degree of modularity needs to be calculated in each case study. And the second is the modularity-oriented refactoring. In this survey, I talked about both the advantages and the disadvantages of modularity and refactoring separately. However, I think there should be a way to incorporate both concepts together to accomplish some achievements since they have some points in common. And this is the references I used when I am working on this paper. Okay, that's all about my paper. Thank you for watching. And at the end of my presentation, I'd like to say thank you to Dr. Huang. Thank you for your help and support during this whole semester. Thank you.